Thank you for coming. My name is Amira Bouguera. I am a computer science engineer and cryptographer at Consensys. Consensys is the largest company working in the blockchain field in the world, and we're basically working on Ethereum. Because one of the co-founders of Ethereum is our CEO, Joe Lubin. So I am a cryptographer at Consensys, and today I'm going to talk about the Ethereum underlying peer-to-peer network. So we'll be talking about what is this protocol that's make Ethereum work, the whole network, and before that, I'm going to talk about myself. So, as I said, I am a cryptographer, security engineer. I'm gonna give a bit of briefing about my professional path. So, I did a bachelor degree in mathematics and computer science, and then a master degree in applied mathematics. And then after that, I did another master degree about cryptography and cybersecurity. At that period, I got to know about the blockchain technology when I was studying cryptography. One of my professors was really passionate about this technology, and he was presenting it to us. So I got involved as well. That was in late 2016, early 2017. And since then, I have been working in the field. So I'm more interested about blockchain in the sense of security and information confidentiality. So everything related to cryptography. I was working so my first job was at Stratum, which is a startup working in the blockchain field, is based in Paris. And after Stratum, I moved to Consensys. That was 2 years ago. And I've been working on information privacy on the Ethereum network. So I'm going to talk a bit about that after. Talk a bit about what I'm doing at my work. It's mostly related to R&D challenges of Ethereum. So before that, let's get to know what is Ethereum. I hope everyone knows, but just giving an introduction. Before Ethereum, so what is the blockchain? Now, to talk about the blockchain, blockchain is a distributed ledger. So what do we mean by that? So we have, so instead of the Web 2.0 system that we have a server and a client communicating together, a blockchain is having multiple servers while storing different type of information. So why do we have that, and what's the advantage of having such architecture? So the blockchain, in fact, appeared in 2009, not as a blockchain as an architecture, but it appeared as Bitcoin, which is a cryptocurrency. So the cryptocurrency Bitcoin appeared as a revolutionary idea to kind of eliminate the need of banks, third parties, centralized third parties, where people cannot trust these centralized third parties, and they want to create a system where there is no need for trust, yet we have a system which is secure. So the blockchain technology helps to create that, and helps to eliminate one of the biggest problems of the Web 2.0, which is a central point of failure, because we have a central point of control. So when you have a certain server and that server is being attacked, so every sort of information can be leaked, can be hacked, or even if the trust party that we are relying on is compromised, then the information, of course, is also compromised. So if you have different servers, let's say 20 servers, which means that unless you have more than a half of these servers compromised, the information is still secure. So that's the revolutionary idea about the blockchain. now to give an idea of what is the difference between the two architectures, centralized and decentralized. So when we say decentralized, we only mean the governance. So the governance is decentralized. However, in the architecture, it's more distributed. So decentralized, which means that it's only in the governance, so there is no only one structure which controls the whole network. It's decentralized, so which means that there are everyone in the network is helping to make that network work and make it secure. And the distributed network, which means that nodes within this network, all of them communicate together and help create that distributed network by communicating using peer-to-peer protocols, which we're going to talk about later on. While in the centralized version, we have only one point which controls every other point that we see on the scheme here. And by attacking that single point which controls everything, the system can be broken. So, okay, now what makes the blockchain technology such an advance? So again, as I said, we do not need a third party, a centralized authority that we rely on and we have to trust on. It doesn't mean that we will eliminate every entity that we trust, but it just means that we will trust them less. We don't have to trust them 100%. We can trust them to give them a bit of information, yet we manage to be trusty that this network will work and will be secure just because we trust the mathematics and the cryptography behind it, not because we trust the people who control it. So, of course, it's protected by complex encryption algorithms. The idea today is not to talk about the encryption algorithms, but I might mention one or two, maybe the signature algorithm. So the blockchain, as we say it, is a chain of blocks. So we have a chain of blocks which store information. So each block stores certain information, and the block afterwards store another information. Now, what makes that information secure and immune to change is that each block stores the previous information. So if you do that, if each block has an information about the previous block, as we call it, the hash of the previous block, if we do that, it means that at any sort of time, if you want to change a certain information at, let's say, block number 100, we have to change all the information afterwards. So what does that mean? It means that, let's say, all these information are transaction. So people communicating together, exchanging money or cryptocurrency, Bitcoin, Ether, whatever. So they're doing transactions and exchanging information. Now, if we store that certain information on a certain block, saying that this person had this amount of Bitcoin at a certain point of time, after that certain point of time, this information will be stored in all the blocks afterwards. So if we go back in time and we want to cheat and say that the person, instead of having 2 Bitcoin, he had 5 Bitcoins. So in order to do that, we have to change all the information afterwards, in the blocks afterwards. So that's not impossible theoretically, but practically it's very difficult to do it. And even if we do it, we can only change one version of the blockchain. And each node of the blockchain, because it's a distributed network, so it's a collection of nodes. So each node of this network will store a current version of the blockchain, which means even if we manage to change a certain version of the blockchain, changing information about one person having certain amount of Bitcoin, we cannot change all the versions stored in the other nodes, unless we are able to control more than 51% of the network, which is difficult if you have 100 nodes, 100 nodes, for example, or even more, that are distributed all over the world. So that's what makes the blockchain technology secure and immune to changes. So that's just to talk about how does it work when people exchange money, and just to kind of like to show what I was talking about earlier. So any sort of information that we exchange is stored in the blocks, and that makes it immune to changes and also makes it transparent. So if we talk about public blockchains as like Ethereum, which I will talk about later on, every sort of information is public. So everyone can see the information and everyone can track everything that's happening on the blockchain. So with that comes maybe a problem of confidentiality and privacy, but that's not our problem today. Our problem today, or at least what we're going to talk about, is how actually can we store these transactions within the blockchain, how these different nodes can communicate together and add blocks one after the other in order to store the different type of information. So when a certain node is able to add a certain block to the blockchain with information, it has to communicate that to all the other nodes within the network. It has to broadcast that. So how does that happen? So the transaction is initiated. It's broadcasted to miners. The miners are the ones which will add blocks within the network and are the ones which are confirming also the blocks. And then the one that add a new block will get rewarded, and that transaction is added to the blockchain. And that's how it's complete. Now, what is Ethereum? Ethereum is a decentralized peer-to-peer network of untrusted nodes, which means that nodes can join freely to the network. We don't need to verify anything about these nodes. They only need to create public, private keys and be able to join the network and connect with the other nodes within the network and execute transaction. Ethereum has the ability to do complex computation. So Ethereum is different from Bitcoin, which I talked about earlier. Bitcoin is more about one application, which is the cryptocurrency. Ethereum is more complex than that. We can imagine it as a big computer that can execute multiple and very complex calculation. So we can create new type of applications which are decentralized application on top of Ethereum. What is the difference? Again, as I said, Bitcoin is more as offering a particular application on top of the blockchain technology. However, Ethereum is focusing on running decentralized application, using smart contracts to do so. What else? Moving on. Okay, now let's talk about the peer-to-peer network of Ethereum and how does that work. So again, going back to saying that these different nodes communicate together. How does that work? How does that happen? And how is that communication is secure? So before talking about how does the peer-to-peer network of Ethereum works, let's define what is a peer-to-peer network. So a peer-to-peer network is an overlay network, which means that it's built on top of the internet. So here we're built it on top of Ethereum, but any overlay network, it's built on top of the internet, and then we use protocols such as TCP for transmission information securely, and then all the different nodes within this network will have different IDs. Those IDs being represented by public-private key pairs. And we'll use those IDs to communicate together and create secure communication. So when we talk about distributed network, it doesn't mean that node number one will be able to communicate with all the nodes within the network. In fact, one node can communicate with nodes which are closer to that node. So geographically, for example. So the nodes that are closer to it, well, we can call them neighbors. So the first node can communicate with them, and then the second node, which is communicating with the first node, also has different neighbors, and then we can create a whole network where we have different neighbors all over the world, which communicate together in a peer-to-peer way. So when we create a link between P and Q, for example, so here just representing when we have different nodes. So, and we trying to create a graph that relates those nodes, or for example, when we have a new one joining X, for example, when it joins, so it can have a direct link with node P and node Q, but it doesn't have a direct link with the node Y. However, node P has a direct link with node Y, and node Q has a direct link with node Y, which means there could be a communication within the whole network. It doesn't have to be one-to-one communication. And this is how we create a distributed communication within these networks. These nodes, sorry. Now, how the peer-to-peer network works for Ethereum. So in Ethereum 1.0, again, I will talk later about Ethereum 2.0, but in Ethereum 1.0, which means the version of Ethereum that exists in right now, nodes speak together using a framework called Dev P2P. So some of them call it RLPx or Dev P2P. So we have different naming, and people name it in different ways. So I'll explain what is the difference between all these namings and what are these protocols that we use in the peer-to-peer network of Ethereum. So Dev P2P is used as a stack which has different layers. So it has the RLPx framework, which is responsible of two things, the discovery protocol and the wire protocol. So the discovery protocol is the protocol that's used to discover new nodes and be able to join a network, the Ethereum network, and communicate with the other nodes. And then the wire protocol is the protocol that allows to do handshaking and saying hello to the neighbor, which we are able to find within the network, and create a secure communication. So afterwards, we can communicate using different sub-protocols that are used within Ethereum, like ETH version 63 or less version 1, etc., or Swarm, or different types of sub-protocols. So now let's talk about what is the RLPx framework and how does that work, and beginning with the discovery mechanism. Sorry, that's just showing the stack to give you a better idea of how it works. So again, as I said, there is a discovery mechanism between the two different pairs. So we have peer number 1, peer number 2. They're using the discovery mechanism to find other peers within the network. Then they use the wire protocol to establish security, trust, and secure communication together. And then afterwards, they will communicate with sub-protocols. So now starting with the discovery mechanism. A node has to find different neighbors within the network. So how does that happen? So for a node to successfully find neighbors within the network, it has to respond to ping-pong pair from different neighbors within the network. So what does that mean? So there is a set of communication between these different nodes, and if a node is able to respond to this communication, then it will be pre-selected to be on that peers that node number 1 will be able to connect with. So how does that happen? How do we choose these nodes? So we use the Cademelia DHT protocol. So if you're familiar with this protocol, it's used with torrent and used in other protocols. And it's a distributed hash table protocol that's very well done, very organized. That's why Ethereum decided to use it. So this protocol allows to find the closest nodes within the network by using the XOR distance. So I'll explain how that happens. So let's imagine we have different nodes within the network. So these represent the nodes. And let's say these are their identities. So for example, 01001, that's the identity of node number 1, and the others are the identities of the other nodes. So if we focus on this node, for example, and we want to find the neighbors of this node that we will be able to add to this table. So why do we add them to a table? Again, because we said a node cannot connect with every other node within the network. It must identify a table of peers which will be able to connect with and then connect with them. And then if that node needs to connect with other nodes within the network, she might ask a neighbor that she could connect with to connect her with the other nodes within the network. So how does that happen? So if we take, for example, the XOR distance, this node, and we XOR it with binary XORing with other nodes within the network. So if we do this this one with the first node, and then we turn it to decimal, we find 15, for example. The value is 15, which is 1111, I think, if we do decimal. So 0, 0, 1, 1, 1, 1. Yeah, so it's 15. So the highest numbers are the ones which are closer to that first node geographically. So what are the highest numbers that we find here? So we find 26, 23, 15, 19, for example. So these are the nodes that are closer to the node that we have in the first one. So when we create the table of connectivity, we identify these nodes as the closest. So again, the one that's with 23 distance, for example, the one with 19, and the one with 26. So these are the closest nodes to it. And then ones that are farthest, for example, this one is farthest, and then the other one are farthest. So we have a saturation depth. What does that mean? It means that after that saturation depth, our node will no longer communicate with the nodes after that. So the node can communicate only with these ones, and they can be their neighbors. But the other ones are not direct neighbors and will not be able to communicate directly with, but will be able to communicate with if she connects with other nodes within the network. So that's the Cademelia DHT protocol, how it works. And Ethereum uses this protocol in the node discovery mechanism. So in order to find nodes, we need to identify some of them which are neighbors, and then put them in a distributed hash table and identify these nodes. After identifying the nodes, when one node decides to connect with another peer and create a secure communication, then we move on to using the RLPx protocol for the handshaking protocol. Yeah, and so that's only to show, yeah, so the identity of these, of each node actually is being represented by the public key of the node. So that's the identity. Well, the identity is the hash of that public key. So these are the different nodes, let's say, for example, within the network. And the node number 1 will communicate and find one that will create a secure communication with. Now, in order to establish a secure communication with one of the nodes that were in the distributed hash table from the neighbors of the first node, so we need to establish exchange of public keys and create handshake using secret messages. So exchanging public keys, this means that if one node exchanges the public key, its public key with another node, it means that they can have a secure communication by encrypting data using the public key of the other peer. So just a reminder of cryptography: in order to send a message, an encrypted message to another person, we have to know the public key of that person. It could be an email address, it could be a phone number, anything that's public and representing that person. So I'm giving you just an example in real life. For example, the bank account. So by knowing that public information about that person, we can use it to encrypt information and send it to that person. So even if we use a channel which is not secure, the other person will be able to read the message in a secure way by decrypting it. And because we encrypted with the public key of that person, only that person can decrypt that message, because only that person has the private key which is associated to its public key. And because we have a pair of public and private keys, it means that no one will be able to decrypt the message unless they themselves have the private key of the person we want to send the message to. So that's how asymmetric encryption actually works. So anyway, so in the establishing the TCP encrypted and authenticated sessions, so we exchange public keys, we create handshake between these two peers. And of course, we have to keep using the ping pong messages in order to make sure that the session is still alive between the peers, and to prevent also from DDoS attacks. And also afterwards to agree on mutual capabilities of each node. So the capabilities, we will talk about them later on, but these are the sub-protocols used by each node. So each node within the network doesn't use the same protocol, and some of them use different type of protocols. So in order to find the one that we can communicate with, we have to know their capabilities and if the capabilities match or do not match. So okay, so now to initiate a session of communication between two peers, peer 1 and peer 2, there is, of course, an initiator, and the other party, we call it remote. So the initiator is the node initiating the communication. After finding different peers within the network, it will choose one to communicate with and then initiate communication. So at first, there will be authentication between both these nodes. So authentication by generating so we generate that authentication message using the public key of the other node, and then the other node will respond with respond with the authentication message. And then after creating the authentication handshake, which is the first one here, then we move on to saying hello to the other node. So each node will derive a secret value. So here, for example, like the AES encryption protocol, so it will derive a secret from AES, from the MAC, from egress, which are protocols used in here, but we'll not talk about them. So the wire protocol, or the protocol used to initiate the handshake, will allow these two nodes to say hello, and then be able to create a secure session by exchanging, of course, the public keys, and then creating a secure session for communication. Now, after initiating the conversation with a node that we find, now we have to exchange information. So what type of information should be exchanged in order to know whether can we communicate with this node or not? We have to, of course, using the RLPx protocol, we have to exchange information about the sub-protocols. So the sub-protocols that they define actually a set of messages transported over the RLPx connection. And the type of messages or information that will be on the sub-protocols, or the messages that we can create with the different sub-protocols, it could be Ethereum data from blocks, headers, transaction, for example, any other information about what's stored on the blockchain. So when a new node wants to join the network, it needs to communicate with other nodes, and of course, it needs to use these sub-protocols to recover information from the network, from the Ethereum network. So from transactions which are stored on the network, headers, blocks, and the sub-protocols, they differ from one another. There are different protocols, and each of these protocols has a set of messages different from the others, or a way of using. So for example, the ETH version 63 so it has information as blocks, headers, transaction from the Ethereum. So that's the one used in Ethereum and used to sync the Ethereum clients in order to synchronize with the whole chain and be able to store the updated version of the blockchain. There is another one sub-protocol called the Light Ethereum sub-protocol, which is a different protocol used only for light clients. So light clients differ from normal clients as they only store block headers and do not fetch all type of information within the blockchain. So they do not store every sort of information within the blockchain, and that's why we call them light clients. So for example, if one node supports the light Ethereum sub-protocol and does not support the ETH version 63, and the node that we want to connect it with supports a different protocol, these nodes cannot communicate together, and the communication mechanism will have to be broken, and then we do again another search until we find the node that we can communicate with and exchange information with. So there are also other sub-protocols used, for example, like in Swarm. So Swarm is similar to IPFS, if you know. So in IPFS, we use P2P, for example. In Swarm, we use the BZZ, which is a protocol also in Swarm that's used also between the different nodes within the network. So Swarm is also it's a distributed protocol that allows to store information. So it's not a blockchain, but it allows to store a different type of information. So it's more like the Web3 kind of version of the internet, which will able to store any type of information on it. And there is also the Parity Warp Sync, for example, the Parity clients. So now, how do we negotiate information about these different sub-protocols? So the nodes have to collect shared capabilities between the initiator and the remote, so the peer number 1 and the peer number 2, in order to know which type of sub-protocols they support, and then pick the highest version for each capability, and then doing handshaking if they match. So to show you how that happened, for example, let's say node number 1 wants to connect with the node here, node number 2. So they exchange different type of information about the sub-protocols they both support. For example, node number 1 supports the ETH62 version, the ETH63, and the less version 2. And the node number 2 supports ETH63 and SHH3. So since both of them support the ETH63 version, the sub-protocol, they will be able to connect and establish a TCP connection in order to communicate afterwards. So that's basically what happens in order to create that, to exchange information about the sub-protocols. Now, the problem facing Ethereum 1.0, or at least the dev P2P protocol, is actually concerning the first protocol in order to find new nodes to add them to the network. So the current version, which is called Discovery version 4, used in Ethereum 1.0 in order to discover new nodes and add them to the network. It doesn't allow to exchange all type of information before creating the communication. So what do I mean by that? If you remember when I said that when we discover new nodes within the network in order to add them to distributed hash table for the neighbors that we can connect with later on, the only thing we were collecting was basically the XOR distance in order to know whether these are neighbors or not. So we do that, we add them, and then we try to create a connection, a TCP connection by doing handshaking messages. However, the problem with that is that sometimes we'll be able to discover peers in other networks. So for example, if a node in Ethereum wants to find other nodes within the network, she might end up finding a node in Ethereum Classic, for example. So we will use the discovery protocol, everything will go well, the node will be found, no problem will be set, and then afterwards, after creating that communication and creating the TCP, then we'll find out by communicating the capabilities that the capabilities do not match, and these nodes are from different networks. And then we go back to zero phase and create a different connection again and again. So this introduces a noise across the shared network. And because it does not allow to share capability information between these different peers within the discovery mechanism. So the Ethereum 2.0 wants to solve this problem, or at least it's doing so. So in the Ethereum 2.0, which will, the Serenity will be implemented in 2022, I guess, for Ethereum 2.0. But anyway, so people are already working on the discovery version number 5 in Ethereum 2.0, and this mechanism will allow nodes to discover information about more metadata about other nodes, which means that we will know more about their capabilities even before connecting with them and creating handshake messages. And we will know more about any type of information that's related to any type of protocols they support or do not support. And by doing so, it will optimize the time of connection and will take off basically all the noise and make the connection faster and even better, because we do not have to break the connection again and again in order to find the right nodes to connect with within the network. So Discovery version 0.5 will be implemented in Ethereum 2.0. That will be in 2022. So other than this problem, I guess So far, the peer-to-peer protocol is being used. No issue with that. So yeah, so basically this. Thank you.